Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we talk about how to use the Pythagorean Theorem. We're in the Common Core Standard of Geometry, and we're going to be understanding the Pythagorean Theorem even more today. We're going to get to know the ins and outs of the Pythagorean Theorem. It's going to be like a brother to us. Alright, let's use the Pythagorean Theorem to solve real-life problems. You ready? I bet you are. Let's do it. Alright, now the Pythagorean Theorem is pretty cool. If you think about any sort of baseball diamond, it's usually, you've got this square here, and you can find out the distance by using the Pythagorean Theorem of how far it would be for, say, the catcher to throw the ball all the way to second base, just by using the Pythagorean Theorem. Alright, and it'll help you find other dimensions as well. So let's do that. Everyday use, you use it in your jobs, your homes, and you don't even know it. Okay, so here is an example of the baseball diamond. Now, what's the distance from the first to third base? We talked about going from the catcher to second base, but if this is 90 feet, that's 90 feet, 90 feet, 90 feet. How on earth could you find it using the Pythagorean Theorem? Well, I'm going to tell you how. All you got to do, 90 squared, because that's a leg, and that's another leg. 90 squared plus 90 squared equals x squared. Simplify it down, and you get 8100 plus 8100 equals 16,200. And if we're going to reduce that, take the square root of it, what on earth is the square root of that number? Well, I'll give you a hint. You break it down factoring, like you've learned in the past, and it becomes 2 times 81 times 100. Well, that's even easier. What's the square root of 81, and what's the square root of 100? So that's 9 times 10. So it's 90. Alright, 90 times the square root of 2. That's interesting. What were the original leg lengths? 90 and 90. It's 90 times the square root of 2. That's something that you can remember as a pattern. If the legs are the same length, just put the leg number there and multiply it by the square root of 2. Pretty cool. Alright, is something a right triangle? If a squared plus b squared equals c squared is true, then that triangle has to be a right triangle. You can work backwards. So let's do this one. Is this triangle that's formed from home to first base to the pitcher's mound a right triangle? Well, it's 90 feet there, 60.5 feet there, 63 7/10 feet there. Is that a right triangle? Well, take 60.5, square it, add it to 63.7 squared, and does that equal 90 squared? Just like this. Is that true? Let's see. Well, what you end up with is that when you add those two together, you get 87.85. So no, it's not a right triangle. Man, it's sure close though, isn't it? 87, 88 to 90 feet. It's not exactly a right triangle, but it's pretty darn close. All right, how high will the ladder go on this building? All right, the fire truck is 8 feet tall. It's 28 feet away. How tall will the ladder go on the building? Now notice, it starts out at 8 feet, so when you get x, you got to add x to 8, okay? So here's the right triangle. 110 is the hypotenuse. 28 is that leg on the bottom. All right, find the missing lengths and then find the perimeter. Try and find x here by doing 4 squared plus 6 squared. Take the square root of that number and that gives you x, then find the perimeter. Same thing here. How do you find x down there? Well, notice there's a triangle here. You're cutting off 2 feet from the 4 feet, so this is 2. So 3 squared minus 2 squared. Take the square root of that, and that would get you x there. Okay? All right. There it is. There's your answers. All right. If you love basketball like I do, the distance from the free throw line to the tip of the rim, from the free throw line to the tip of the rim is 16.4 feet. Well, from the free throw to the basketball hoop pole is 15 feet. So from here to there is 15 feet, and from the pole to the rim is 2 feet. So this is 2 feet. This total distance is 15 feet. What's the distance of this basketball hoop to the ground? What's the distance? How tall is this basketball hoop from the floor? All right. Is this a right triangle? Notice anything peculiar about the numbers? Maybe multiply them all by 3 and see what happens. See what kind of triangle you get. All right. So yeah, it's 10 feet high is that basketball goal. And yes, that's a Pythagorean triple. If you multiply each of those by 3, you end up with a 3, 4, 5 triangle, which is a right triangle. All right, well that's it today as we talk about the Pythagorean theorem solving real life problems. Are you able to use it to solve those kind of things? I bet you are. It's pretty cool when you can use that math to do real things. Like find the length in a baseball diamond. All right. Well, this was Matt with mathmath.com. Thanks for joining us here today. Check us out on Facebook, Solving Maths Problems, and on Twitter, Maths Math, and enjoy math.